What people focus on is how to learn Python, Excel, Power BI, and they are so overwhelmed that they start working on the project and they don't know how to even replicate those projects themselves, even when they watch YouTube video. First of all, welcome to my cyberspace. In this video, I'm going to be talking to you about some of the technical terms you need to know or data analysis techniques. And in the last videos in this particular series, I've spoken about some of them. And let's jump right into it. So this particular part, I'm going to be talking about important subcategories to learn as a data analyst, type of variables, and analysis and statistics. So the next thing you want to ensure is what is a variable itself. A variable is a characteristics or part of your data set that could vary or change. So you have 8, 6, those things could change. And for variables, we have two major type of variables. We have categorical variables and numerical variable. Some people can think of variable in a different approach, but let's think of it from this approach first of all. So for numerical variable, this is something that would say a lot as data analysts. If you cannot differentiate between what is a categorical variable and numerical variable, most of your analysis will fall flat. So numerical variables are variables that can take on numbers. So they usually include height, weight, temperature, and income. There's also a subcategory for numerical variable. Categorical variables are variables that represent groups. So they can take on values that represent different levels of labels. So most likely like marital status, type of cars, gender. You can also have things that are numbers like 1 and 0. That's, for example, you collect a data set, people that are rich or poor. Rich feels 1, poor feels 0. You can think, oh, that's a numerical variable. Actually, that's not a numerical variable. So that is actually a number in that is a categorical variable. So you give people an ID. Their ID number is 001, 002, 003. From an analysis standpoint, that is also not a numerical variable. In fact, we might maybe categorize that as a categorical variable, but we might not. But it just depends on how you're thinking about it. So for numerical variable and categorical variable, we do have two types of numerical variable. You're like, hey, I want to learn data analysis, I don't want to learn statistics, but this is really one of the things that you need to know, the fundamentals for you to excel in this field. So keep watching and don't skip this video. So for numerical variable, we have two. We have continuous. So continuous are numbers that are basically decimal, like 2.1, 2.3. It doesn't mean that if a number is if it's not decimal, it's not continuous. It just means that number can possibly be decimal. So imagine somebody is 550, right? Another person could be 501. So it just depends on the context. But things like age, you can't be 18.2. I mean, people say, yeah, I'm 18 years and 2 months, but that's not correct. So those are like, you say, well, I have 3 and you have siblings, except you have step siblings. But we know like you can only have like 3 children or 4 children. There's not like half of that. So that's when we mean discrete numerical variables, and we have continuous numerical variables. So for categorical variables, this is very important. We have binary, we have ordinal, we have nominal variable. For binary variable, these are like variables that can only be like yes and no, or like 2 levels. So when it depends on the number of levels you have. So we have those levels. So binary are like yes and no, male and female. I mean, we know right now there's like different levels of gender or sex as well, but normally it's like if you use just 2 levels, that's a binary variable. Ordinal variables are, the way it sounds, ordinal is like the category is ordered. It's not just a category in itself. So when you have agree, disagree, or somebody posts a grade like excellent, good, very good, good, poor, very poor, right? So although it's category, but like that ordering still makes sense. So somebody gives a star rating of 5, 4, 3, 2, 1. Right now, that is the category in itself, because it's like one category. The next one is as the ordinal, and then you could pause this video to get to like read this script better. And there's a nominal variable. So these are like categorical variables that represent categories of group with no inherent order. Like it's literally like blue, green, white. Either you say green first of all, or maybe it's the best color, but it doesn't really matter. So the next point is examples of what are the examples of a numerical and categorical variable, right? And let's identify those that are continuous, ordinal. So we know that obviously this is a numerical variable, and this is like a continuous numerical. This is a discrete numerical. We know this is also a categorical variable. This is a bivariate. This is also bivariate. And rating, which is 1, 5, 2, 2. This is number, but this is also a categorical variable because it's a category. And this is an ordinal, like categorical variable. Marital status, this is a nominal categorical variable. Just understand that. So another type of variable that you could think of, it just depends on the perspective at which you're thinking about variable. So we have something called dependent variable, independent variable, mediating variable, moderating variable. So for dependent variable, these are outcomes or represent responses that may influenced by change in the independent variable. In other words, they are the effects in the cause and effect relationship. So when we say dependent variables, so you say something like, oh, I ran 100 kilometers and now I'm tired. You being tired is the dependent variable. So something is causing something. The effect of something is actually mostly in the dependent variable, and think of the reverse in the case. So for the independent, the cause in the effect is in the cause and effect is actually the independent variable. So I'm using all of these terms so that you can understand, because it necessarily might not make cause and effect. It just means that this is how to think of it to be able to understand better for everyday analysts. Mediating variable, they provide insights into the mechanism or the process in which the independent variable influences the independent variable. So most of the time when you say things like, oh, like I'm hungry, then I fall sick. So what makes you fall sick is not just the hunger in itself. There might be like there might be the fact that because you're not eating, then there is your body is eating up itself. Like those are the things that you don't have the energy. So there are things in between. So X eventually like influences Z, that then eventually influences Y. So that's like when you think about mediating or moderating. Moderating is the fact that so something is actually happening between, we can say that, oh, for male and female, we can say first of all, like people when they don't eat they fall sick, but this is actually different for people who live, let's say, in Africa versus North America or whatever it is. So it just depends on how you're thinking about it. So that's moderating variables. Examples of variables is, so there is an association between ice cream sales and death rates, if that's actually true. And so the death rate here is also known as Y, which is the dependent variable, while the independent variable is ice cream sales. So the mediating variable is that, so it's because of the time of the year, so people get to visit the beach, and which is also known as Z. So that is like, so people, so it's not ice cream that's necessarily influencing death rate. Is that people have to go to the beach first of all before then they go purchase ice cream. Then there's high crime rates because people are more gathered together during the summer. Does that make sense? Then moderating variable is that, oh yeah, this is differ by gender or by wealth status. If you're not rich, you probably might not go to the beach, or then you might not be caught up in people that are killed. So when we talk about type of analysis, remember this video we're still talking about subcategories. So type of analysis, there are different types. We have quantitative, qualitative, and we have mixed method. So for quantitative is mostly what you're watching a lot of videos about. They're telling you how to use Excel, Power BI, Python. Most of the things is quantitative analysis. But there's a type of analysis that is qualitative that you literally might not even analyze numbers. Is you can analyze my conversation, you can analyze movies, you can analyze, when they do like some interviews and they start asking people questions, either a TV interview or it's a group interview whereby they're asking people questions about a particular subject and it's open-ended. So for them to analyze that is actually called qualitative analysis, and there are different tools for that. We have Atlas TI, we have Vivo, depends on if you want to go in that route. That's a field that you could go for. I made a separate video on like various analysis field. You could go check that out. Mixed method is if you have to use both and qualitative and quantitative analysis in your approach. Tools, we have quantitative tools, Excel, Power BI, Python, and we spoke about that already. What are the examples of quantitative and qualitative analysis? So let's try to identify qualitative and quantitative. So when you ask a question, what is your average? What is your rating of this product? Somebody says above average, average, below average. That is quantitative. You ask the person, what's your opinion about this product? Then you remember when you buy that product on Amazon or whatever platform, and they ask you what's your view of this product, and they start to you start to write all these stories. So what they're actually doing is qualitative approach, and eventually, there's a way to do this in Python. You do sentiment analysis based off of some keyword, but the detailed approach is when they analyze all of those statements from yourself and other people, is they have a comprehensive report that they can present to the stakeholders about what people are saying about the product. So hope that makes sense. So another thing you would also want to know is the levels of analysis. A lot of times this is a little bit complicated, but let's explain a little bit. So levels of analysis, we have univariate. Univariate is you're just thinking of a question, just one variable. How many people are there? How many males do we have? or how many respondents. So you're not considering two variables in your analysis. Why bivariate is you are considering two variables when you phrase your question. Remember, before you write your analysis or you do any analysis, always have questions in mind. There's always an ask, there's always a why. What are we doing before you jump into an analysis? Then the next thing is multivariate analysis. Is multivariate with sound is having more than two variables as you analyze or come up with questions for your research. And let's think of something that is simple. This is a simple data set. So when you ask what is the average income, this is a univariate analysis. Literally, the only variable I would need to get the average income is to use this income. I'll sum them up and divide it by the number of incomes that we have here. If I ask what's the average income by gender, that goes then to bivariate analysis. So I'm trying to look at this income variable and I'm looking at this gender variable. Then if I say find the average income by marital status and urbanity, right? So this is now multivariate. So in data analysis, another word for by is group. So you can say by, so think of by as group by or differ. So those are like terms that you would use in your project. And we have type of statistics. So we have descriptive and inferential. Descriptive is mostly what people do a lot. So they are trying to like, oh, let's see the mean, the standard deviation. You're looking at the bar chart, dashboard. So when you go in like inferential statistics, that's when you're going a little bit higher. You're making an inference. So based on what we have today, the past trend, what is this data going to look like in the future? That is what we call inferential statistics. Then this can also be called exploratory analysis. There are type of statistics also. Let's look at this. For example, find the distribution of gender and average children born. This is a descriptive statistic. So this question, next one is an inferential statistics, is what will be the predicted number of children for a married woman earning 1,500, right? So there's nobody earning 1,500, yeah, but like how do you predict that? With this data, you can do that. That's one of the beauty of data analysis. And when you talk about like sources of data collection, we also have like primary data, secondary data. Primary data are data that you do collected yourself, and secondary data is data that was collected by a different person. So you are working, you're working on a project, you found data on Cargo, whatever platform, that's a secondary data. You collected a survey for yourself, for your research, that's a primary data. So those are like things that you could know. And examples of data source, you could look at some of these data source here. Cargo, there is World Bank, there's catalog, data.gov. These links are going to be put into the Google into the subscription of this video so that you can get to look at them and have a better understanding of it. Thank you. In case the video was a value for time, do well to subscribe, like, follow and share. In the next series, I'm going to be talking about more things you need to know as a data analyst, and so you can excel and stand out among your peers and other data experts. Thank you. Ciao.